Hi, and welcome back again to neurobiology and 5 minutes or less. And this time, what we're going to be talking about is our bitter receptors. Now, bitter receptors are really interesting because bitter receptors actually exist because bitter things tend to be very bad for us. And so as a result, we actually have more bitter receptors than we do other types of receptors. Specifically, we have way more bitter receptors than we do sweet receptors. This is because there's a lot of variability in things that are dangerous for us, even though we only perceive them to be one type of taste. There's a lot of variability chemically, structurally, in terms of that, as opposed to something like sugars. Sugars are composed of these same fundamental building blocks and typically have very similar configurations. So that's a big factor. The number of receptors that we have are the types of things that they're receiving. Bitter receptors are actually a class A receptor. So this is the first type of receptor that we're seeing that is different than our class C. However, the reason why bitter receptors are being talked about now is because as much as they are different, it's really the receptor that is different. I've actually included down here, we still have the umami one right over here, so I'll write that down next to this. But this is our umami over here. And when we look at our umami, and we look at this up here, I'm actually going to reveal a lot of the parts up here. We can see that this is almost identical to the umami and subsequently the sweet receptors. So the big difference here is our bitter receptors. And again, bitter receptors, they don't have any one type of thing. It's mostly things that are dangerous for us and poisonous for us, or evolutionarily, our bodies know we don't process well, therefore they don't taste good to us. So look a little bit at that. So this is what our bitter receptor looks like, right? It's a T2R. And remember, so far all we've worked with are T1R something, right? So this is automatically a whole different class of receptors. However, it is still a G protein coupled receptor, so we are still going to see this G protein cascade being stimulated. We're still going to see that PIP going into IP and going to the receptor. We're going to see that influx of calcium. We're going to see that influx of sodium as a result. So overall, the mechanism is not a huge difference, but the actual receptor is a huge change away from what we've seen. And again, this is primarily because of the fact that bitter is so different than anything else. And even when we're going to continue in the next video, we're going to talk about salt and sour. Even those two don't have the same number or variability as these receptors, because this receptor in particular is in and of itself just a whole different beast in terms of how many things it has to be able to detect. So we'll talk about those two next video, and then we're going to sum up all of the tastes in one video after that. So stick around.